Do you all have an interest in dinosaurs and ancient giant creatures? I am very fascinated by them. However, why are there not many large animals in the present day? Let's explore some theories to find the answer. The first theory is related to climate change. Climate change refers to long-term alterations in factors such as the average temperature, precipitation, and wind patterns on Earth. Throughout Earth's history, there have been several instances of climate change, including ice ages and warm periods. These shifts in climate are triggered by natural phenomena like variations in Earth's orbit, axial tilt, solar activity, and volcanic eruptions. However, in recent times, the increase in greenhouse gas emissions due to human activities has become a significant contributing factor. As a result of climate change, food sources like plants and small animals may decrease, and habitats may shrink, making it more challenging for large organisms to survive. Herbivores, in particular, require a substantial amount of energy per kilogram of body weight per day, and they quickly weaken if food becomes scarce. Furthermore, with climate change, new pathogens or parasites may emerge or be introduced, and large organisms may have lowered immune defenses, making them vulnerable. In this way, climate change is believed to have a detrimental impact on large organisms. Now, let's explore specific examples related to climate change and the extinction of famous large creatures like dinosaurs and mammoths. First, let's consider dinosaurs. Dinosaurs existed on Earth from approximately 250 million years ago to about 65 million years ago, during which there were multiple instances of climate change. Particularly around 200 million to 150 million years ago, the supercontinent Pangaea began to break apart, resulting in substantial climate shifts. During this period, the entire planet experienced increased aridity, leading to desertification and elevated salinity levels. This reduction in habitat diversity and availability had an impact on the diversity and distribution of dinosaurs. Nevertheless, dinosaurs adapted to these climate changes through evolution. For instance, herbivorous dinosaurs evolved elongated necks to reach taller vegetation and developed specialized beaks to consume lower-growing plants. Additionally, carnivorous dinosaurs adopted bipedal locomotion for increased speed and started hunting in groups for greater efficiency. This adaptive response allowed dinosaurs to thrive once again in the face of climate change. However, what ultimately sealed the fate of the dinosaurs was a different climate shift that occurred approximately 65 million years ago. During this period, a meteorite with a diameter of about 10 kilometers collided near the Yucatan Peninsula in Mexico. This impact released a massive amount of dust and gases into the atmosphere, plunging the entire Earth into darkness. As a result, photosynthesis was hindered, leading to the withering of plants. With a decrease in vegetation, herbivorous dinosaurs starved to death, and in turn, carnivorous dinosaurs faced a scarcity of food. In this way, the dinosaurs became extinct. Next, let's consider the mammoths. Mammoths existed on Earth from around 5 million years ago until about 4,000 years ago. During this time span, there were multiple climate fluctuations. Particularly, between about 200,000 years ago and 10,000 years ago, there was a period known as the Last Ice Age, characterized by frigid temperatures. The entire Earth was covered in glaciers and permafrost, causing a drop in sea levels. This environment allowed mammoths to thrive in vast steppes and tundra, which were dry grasslands. However, what ultimately led to the demise of the mammoths was a warming trend that began around 10,000 years ago. During this period, glaciers and permafrost started to melt, causing a rise in sea levels. This led to a reduction in the habitats suitable for mammoths, while lush environments like forests and wetlands expanded. These new environments were unsuitable for mammoths. Additionally, the warming trend brought about the introduction of new animals and plants, leading to competition and the introduction of diseases that affected the mammoths. Furthermore, human hunting also played a role in reducing the numbers of mammoths. In this way, the mammoths became extinct. The second theory attributes this to human activities. Human activities refer to actions such as agriculture, industry, hunting, fishing, development, and transportation where humans impact the natural environment for their own benefit and livelihood. Humans appeared on Earth approximately 200,000 years ago and subsequently developed technologies like agriculture and industry. In pursuit of their interests, humans have destroyed natural environments like forests and wetlands, and engaged in hunting and fishing, leading to the killing of numerous animals. This has resulted in large organisms having their habitats and food sources taken away or being directly killed. Particularly, giant mammals like whales and elephants are endangered due to overhunting and poaching by humans. In this way, human activities are perceived to pose a threat to the survival of these large organisms. So, what are some specific examples? Let's take a look at well-known giant organisms like whales and elephants and how they are affected by human activities. First, let's consider whales. Whales are apex predators in marine ecosystems, with numerous species in existence. However, whales have been heavily hunted by humans for many years. Especially from the 19th to the early 20th century, whaling was rampant, with whales being used for industrial purposes like oil and as meat for consumption. As a result, whale populations drastically declined and many species became endangered. In 1986, the International Whaling Commission (IWC) announced a moratorium on commercial whaling, which has led to a gradual recovery in whale populations, but they are still not considered entirely safe. Even today, some countries continue to hunt whales under the guise of scientific research or traditional whaling. Additionally, factors like climate change, marine pollution, fishing activities, and shipping traffic also impact whales. Therefore, whales have suffered significant harm due to human activities. Next, let's look at elephants. Elephants are apex herbivores in terrestrial ecosystems, with two species, African and Asian elephants, in existence. However, elephants have also been heavily hunted by humans for many years. Poaching, especially for valuable parts like ivory and skin, has become a serious issue. Ivory is highly valued and traded at high prices for items like ornaments and crafts, particularly in Asian countries. Poachers kill elephants using firearms or poison arrows, extracting only the ivory before leaving. This has led to a drastic decline in elephant populations, with many regions facing the threat of extinction. In 1989, the international trade of ivory was banned under the Washington Convention, leading to a temporary decrease in poaching. However, in recent years, poaching has been on the rise again. Additionally, habitat destruction and changes to factors like agricultural land and development also impact elephants. Hence, elephants suffer significant harm due to human activities. The third theory is based on the distinction between viviparity and oviparity, which refers to the differences in how animals give birth to their offspring. Viviparity involves the development of the embryo or fetus inside the mother's body, culminating in a live birth once a certain level of maturity is reached. Nearly all mammals exhibit viviparity. In contrast, oviparity refers to the method where eggs formed within the mother's body are laid and hatched externally. The majority of animals, excluding mammals, are oviparous. Viviparity and oviparity differ in the ways they nurture offspring and associated risks. In viviparity, the mother undergoes a prolonged period leading up to birth, which can entail energy expenditure and risks from predators. The size of the fetus or embryo is limited by the mother's body size. However, the growth within the mother's body increases the survival rate of the offspring, as they receive nutrients and oxygen from the mother and are not directly exposed to the external environment. After birth, mothers continue to care for their young through breastfeeding and protection. In oviparity, the mother can separate from the eggs after laying them, but the eggs are susceptible to environmental factors such as temperature and humidity, and they are often targeted by predators. One advantage of oviparity is that egg size is not limited by the mother's body size, allowing large organisms to produce offspring relatively easily. As a result, viviparity and oviparity differ in terms of the efficiency and safety of offspring care. While viviparity can pose challenges for large organisms during birth and parental care, oviparity enables large organisms to produce numerous offspring. So, what are some specific examples? Let's take a look at the characteristics of oviparous giants like dinosaurs and reptiles, as well as viviparous giants like mammals. Firstly, dinosaurs and reptiles are oviparous. They lay eggs and then often depart. They have limited thermoregulation abilities and are suited to warmer climates. Oviparity allows them to lay eggs without being constrained by their body size. However, dinosaurs and reptiles are believed to have had weaker instincts for protecting eggs and offspring, making them highly vulnerable to predators. They may also have been less adaptable to environmental changes such as climate fluctuations and asteroid impacts. Now let's consider mammals. Mammals are viviparous, with mothers nurturing their embryos inside their bodies. They have strong thermoregulation abilities, enabling them to adapt to cold climates as well. In viviparity, the size of the fetus is restricted by the mother's body size, which limits the potential for mammals to reach the enormous sizes seen in dinosaurs and reptiles. However, mammals exhibit strong protective instincts for eggs and offspring, providing care through features like breastfeeding and thermoregulation. They are also thought to have been more adaptable to environmental changes such as climate fluctuations and asteroid impacts. The fourth theory is based on the relationship between gravity and muscles. Gravity and muscles relate to the force required to support the body of organisms on Earth. Gravity is the attractive force proportional to the mass of the Earth, acting on objects on its surface. Muscles are the tissues that contract to move the organism's body, attaching to the skeleton and organs. In the interplay of gravity and muscles, the size and shape of an organism's body are constrained. In the relationship between gravity and muscles, as the size of an organism's body increases, the amount of muscle needed to counteract gravity also increases. However, muscle mass is proportional to the surface area of the body, while the weight subjected to gravity is proportional to its volume. Consequently, as the body size increases, the ratio of surface area to volume decreases, and the ratio of muscle mass to body weight also decreases. This implies that as organisms grow larger, they become unable to withstand gravity. So, what are some specific examples? Let's look at the differences between large land-dwelling creatures like dinosaurs and mammoths, and ocean-dwelling creatures like whales and squids. Firstly, dinosaurs and mammoths. Dinosaurs and mammoths were terrestrial creatures that required robust muscles and skeletons to support their own weight. Dinosaurs existed on Earth from approximately 250 million to about 65 million years ago, during which time various environmental changes such as climate shifts and asteroid impacts occurred. These changes demanded adaptability and mobility from dinosaurs. However, their enlargement increased the burden of gravity, leading to a decrease in adaptability and mobility. This ultimately led to the extinction of dinosaurs. Next, whales and squids. Whales and squids are marine creatures that did not require strong muscles and skeletons to support their own weight. The high density and buoyancy of seawater meant that marine organisms experienced less strain from gravity. Consequently, whales and squids were able to enhance their adaptability and mobility without concern for the increased gravitational load that comes with growing larger. This has allowed whales and squids to thrive. This time, I talked about the reasons why gigantic creatures don't exist. Due to natural laws like climate change and differences in oxygen levels, colossal organisms cannot survive. However, conversely, this means that we humans and other animals are living in harmony with nature. I believe it's important to appreciate and protect the environment. If you found it interesting, please subscribe and give it a thumbs up. Stay tuned for the next episode. Thank you.